Hey, so in this video, I wanted to go over the solutions to the identifying acids or bases worksheet. All right, so just a quick review. There's two definitions that you can use to identify acids or bases. All right, so something is either an acid or a base in a particular role. The question is, what information is it that you're using to make that identification? All right, according to the Arrhenius definition, acids are things that either generate H3O plus or H plus in water. All right. Bases are things that generate OH minus when added to water. All right. According to the Bronsted-Lowry definition, acids are H plus donors and bases are H plus acceptors. All right. The thing is, in a lot of equations, something could be identified by either definition. All right. So let's give some examples. All right. So if I showed calcium hydroxide dissolving in water to make these ions right here, could we identify this right here? All right. This would be a base because of the Arrhenius definition. All right. If you take a look at the Arrhenius definition of a base, it's something that generates OH minus, and what we should say is when reacted with water. All right. And that's what happens here. All right. Notice we could not use the Bronsted-Lowry. There's nothing about this saying that this is accepting a hydrogen the way this is drawn. All right. In the next case, all right, this is well, the name of this is nitric acid, but like, how could we show based on this equation that it's an acid? All right. There's actually two different ways that we can identify this. All right. First of all, is the fact that when it reacts with water, it generates H3O plus. And by that definition, by looking at this that way, we could identify it by the Arrhenius definition because it generates H3O plus when reacted with water. All right, but there's another way to look at this, and that is to recognize that when this happens, the HNO3 gives its H plus to H2O. So that results in the NO3, which no longer has the H plus, and the H3O plus, which is what happens when water gains that H3O plus. All right. So, by looking at it that way, since in this role right here, this thing is donating an H3O plus, that makes it an acid by the Bronsted-Lowry definition. Notice that in by both definitions, it is an acid. All right. And just to use an analogy, like, if you were to look at somebody's, great grandfather, all right, you could identify that person as being old, number one, by their appearance. All right. Most likely they're going to have some signs of aging. But number two, you could identify them if they were to show you their driver's license, all right, which gives you their birth date. All right. Notice that both, they're both ways to determine age, and generally those ways are going to be, both of them lead to the same conclusion. All right. In this case right here, all right, notice that this is a base notice what the reason that we can do that is that it accepts an H plus when this happens. All right, so it's a base according to the Bronsted-Lowry definition. In this case right here, water. All right, and it might sound weird to hear that water is either an acid or a base. I thought that water is neutral. All right, pure water all by itself is neutral. All right, but in chemical like if you add water and put it in the presence of an acid, it's going to act as a base. All right, so notice that we're saying it's acting as a base in this reaction. All right, and it does that according to the Bronsted-Lowry definition. All right, so in this case, all right, notice again we've got water right here, and in this case, the water is it is donating a hydrogen to this material right here. Therefore, it's acting as an acid, all right, according to the Bronsted-Lowry definition, all right? And notice what I'm saying on this worksheet is I'm saying that something is acting as an acid or acting as a base, all right? And the analogy that I give before is that, like, that offense defense, all right? We know that quarterbacks, we generally say that they're offense, but Remember, there are situations like after an interception or a fumble where they act as defense. All right, so offense or defense specifically literally means the role that something is currently partaking in, even though it might normally have another role. All right. In this reaction, notice that this material right here, it accepts a hydrogen when it goes to here. That makes it a base according to the Bronsted-Lowry definition. And whenever I give just one of them, like I'm saying that because there's no way I could have identified this as a base according to the Arrhenius definition. If you could do it either way, I'm going to try to make a point of saying you could do it by either definition. All right, this one right here, the only way that you can identify this is by saying that it is donating a hydrogen to this thing right here. So that makes it an acid by the Bronsted-Lowry definition. And this right here, KOH, when dissolved in water, makes hydroxide ions. That makes it a base according to the Arrhenius definition. All right, this material right here would be a donor of a hydrogen. So it donates a hydrogen H plus to this guy right here. That makes it an acid by the Bronsted-Lowry definition. This material right here would be a base according to the Arrhenius definition because it generates OH minus, right? This right here, so in this role, it is giving an H plus to this material right here. That makes it an acid by the Bronsted-Lowry definition. All right, and I wanted to go ahead and add one more because I didn't have anything so far that could only be identified as an acid by the Arrhenius definition. But if I were to draw a reaction this way, right here, HCl reacting with water to make H plus aqueous plus Cl minus aqueous. All right, again, this is that case where people will draw it this way, even though there is no such thing as aqueous H plus. But if it was drawn this way, the only way that you could identify this is as an acid is by the Arrhenius definition. Notice that you don't see it being the H plus being donated to something else, all right, the way that this is drawn. So hopefully that helps, and we will see you later.